share my screen. This is the agenda for the week, and we will wait 2 minutes and start at 8. How's everyone this morning? Fabulous, I'm sure.
Doing very tired.
Tired?
Yeah.
How come, Robert?
My dog wanted to sleep on my bed all last night.
Ah.
Practically pushed me off in bed.
A greedy dog.
Yes, she is.
Yeah, we have 2 dogs, but we have pens for them. So we put them in their pens overnight.
Yeah, we tried doing a cage for her when we first got her, but she did not like it.
Yeah, and they behave pretty well. They're
we have a little dog bed
well
for her.
behaved.
We have a dog bed for her, but she doesn't like it. She just likes sleeping with us.
Yeah. Yes.
She
loves to jump on my bed, one of my 2 dogs, and play, but that's not where she sleeps. That's just where she spends some time with me watching TV.
Yeah, so I was like up at like 4 o'clock, just staring, awake at bed, just waiting. Like, why don't you just move, please?
Are you a coffee drinker?
Yeah, I'm drinking a big coffee right now.
Okay, good. That will probably help.
Yeah.
All right, it's 10 o'clock, everybody. Let's go ahead and get started. This is the agenda for the week. So we started chapter 4 on Thursday of last week, and we're going to finish chapter 4 today. We're going to do a little bit of a review. I don't want to go back to the very basics, but I want to do a review, and we want to finish chapter 4 today. And then we're going to finish chapter 5, which is IDS, IPS, intrusion, detection, intrusion, prevention, on Thursday. And it shouldn't take us that long to do that. And I'm going to be focusing on IDS, IPS at about 1,000-foot level. We're not coming down to the ground level. We'll do a lab or 2. I think we only have 2 labs for chapter 5, but we're not really going to dive too deep into it. So this is the plan for this week, just to show you the big picture right here. Okay, so we're finishing 4 this week. We're finishing 5 on Thursday, and then we still have quite a few chapters after that. I was looking at the assignments earlier today for chapter 10, and they all have to do with ASDN, which is a utility which we can't use with Packet Tracer. And now I need to figure out what to do with it. This is usually a utility that we can use on campus. It's not going to work with Packet Tracer, and all the labs are ASDM labs. So we'll figure something out. We may not have any labs for chapter 10, or I may invent one for chapter 10. So let's do a review. Any questions before we start? So very quickly about the assignments, I do need the Packet Tracer files. So I still have a handful of students that complete the PDF and then they upload that. Great, thank you. I appreciate that, but that's not enough. I still need you to build, configure, and test the Packet Tracer file. And please, everybody, test your Packet Tracer file before you upload it. Sometimes we have basic networking issues, like computer A cannot communicate with computer B, which means nothing else is going to work. And it's like, gee, that's a really easy one to test and troubleshoot. So I hope you are doing the quality check that is required before you consider the lab done and before you upload it. Okay. I'm done with this. Okay. So this is where I want to start my review. I hope you remember those guidelines. You really need to get your brains around those guidelines. There's no escaping ACL. ACL is a skill, is a must, no skill. ACLs is a must, no skills. There's no avoiding it. Every morning you go to Gmail, every morning you go to Facebook or wherever you go. Yes.
I had a quick question. I kind of just dropped in. I caught the last part of that. You were talking about the weekly labs.
Yes.
So what is the expectation on that packet tracer when we turn it in? Will it be different based on each week, like what works and doesn't work? Or are we always expected that the routing protocols will work, that PCs can ping each other? Like what's the...
It depends on the assignment. Some assignments expect you to configure that, and some assignments will give you a packet tracer file with basic networking working. So
okay, so it's going to be different per week or
it's
per assignment?
It's going to be different. Yes, Alex, it will be different per week. And do as much as you can. So by now we all understand there are some packet tracer limitations, and I don't expect you to overcome those limitations. But it's quite capable. I find packet tracer quite capable, and it has many, many advantages over physical devices. And one of them is being able to run it on any computer from anywhere. And
I'm wondering if we can get some direction, I guess, on what's expected each week.
What is expected each week is that you upload a packet tracer file that works. So that's
okay, but that's going to be different each week, is what I'm saying, right?
Yeah. Yes, it will be different. Yep,
like the definition of works.
The definition of work depends on the lab, and you can go down that PDF and see what the expectations are. And you may not be able to get all 10 capabilities working in packet tracer. But whatever packet tracer supports, I expect to be working.
Okay, sort of. Will you be shining any light on what you expect to work each lab, or is it up to us to kind of guess what the goal is there?
Yeah, I expect you to go down the list and check each item, except for the items you can't check because there is no packet tracer command to do that. And then you can skip that and move on. But just but start from the top, work your way down, and yep, packet tracer supports this, and make sure it's working. And packet tracer doesn't support this, be creative.
Well, I mean, like last week, I think that auto secure messed up router 3. So without you having stated it in the assignment, I wouldn't know that you expected OSPF to work after those commands. So I'm just wondering in the future if you'll tell us you expect it to work, or...
I didn't know that either, Alex, but I do expect you to test it when you're done. I didn't know that auto-secure would corrupt, and I'm not even sure if that's the case. I'm not saying...
Yeah, I don't know either, 100%, but...
Yeah, so I don't know what happened, but just do a test before you upload. I don't think that's unrealistic expectation that, yep, all the stuff I did before is still working. And if you find out that task number 10 is screwing up the previous tasks, make a note. Say, Zico, I did task number 10 and it screwed task 1 through 5. And you may want to leave task number 10 out and make a note. So we're all adapting to packet tracer, and there are some constraints. And I don't know what else to say.
Yeah, I mean, I guess it sounds like we're responsible to figure out what works and doesn't in packet tracer. I don't know.
It sounds like a strong statement, Alex. I mean, you're just working your way down the PDF, and there are some commands you can do and some commands you can't do. And
I guess I just mean like packet tracer will take like half of the commands for one whole section that doesn't work in its entirety. So you get halfway through the commands, and then you go to pass one that maybe you want to encrypt it with a certain form of encryption, and packet tracer doesn't support it. And then you're halfway through, you've already configured half those commands, and the packet tracer is kind of messed up. So what do you do?
Let's stick with that example for a second. So it doesn't support a particular encryption protocol, then be creative and use a different one that packet tracer supports, that we've done labs for as a part of the lecture. So if it doesn't support this protocol, fine, I will use a different protocol and I will keep rolling. Or you can make a note and say, Zico, it didn't support this protocol and I hit a wall, and I'm okay with that too. But I prefer you be creative, and that's an important skill in every job, just being creative and finding ways around the challenges you come across. All right, if you want to chat some more about it, Alex, I'll be happy to stick around afterward and we can talk about it, but I'd like to go back to the agenda. So back to the guidelines, everybody. This is really important. And I'm not going to go over it one more time, but this is really important. And ACLs are really important. And there is no escaping ACLs. There's no escaping firewalls. Every single time you go anywhere, you're going through multiple firewalls. And each one has to allow you, permit you, or that would be the end of that session. So let's make sure we're comfortable with ACLs and firewalls. Okay, moving on. I'm going to skip over this. Okay. ACL IP v4 v6. So we all know v6 came much later than v4, so we don't have basic and extended. We only have the equivalent of extended in v6, and we don't have numbered and named. We only have named. So when they created v6 many years after v4, they said, you know, let's not deal with all the legacy stuff. Legacy stuff is standard and legacy stuff is numbered. And the rest of it is the same. So an ACL is an ACL. There are some differences, and we will touch on them today, but fundamentally they're the same. We just don't have standard and extended, and we don't have numbered. It's only named. So we allow, we deny. So we have an access control list, and you're going over that access control list sequentially. And when you're denied, that's the end of it. When you're allowed, that's the end of it. So let's say you have 6 statements in that access control list. Let's say you have 6 ACEs, access control entries. And then the first entry denied, you're done. You're never going to get to 2, 3, 4, 5, 6. And if the first one allowed you, you're done. So as soon as there is an allow or a deny, processing stops and you're in or you're denied. Or you don't meet the criteria and then you move on to the next ACE. So you say, yep, that doesn't apply to me. The first ACE doesn't apply to me. I'm talking TCP and this is a UDP ACL. Okay. So there are only 3 decisions, you know, allow, deny, not applicable, move on. Everybody? Allow, deny, not applicable, move to the next. This is a great slide, everybody. It talks about the different kinds of firewalls, and we have many different kinds of firewalls. Fundamentally, they all do the same things. They filter inbound traffic, they filter outbound traffic, they use ACLs. So let's start with the first one, packet filtering. This is what we call stateless. This is what we have been calling a stateless firewall. And you can see this is a great slide, you know, it operates on layer 3 and 4. There is no layer 5. Layer 5 is the session. Layer 5 is what makes it stateful. I initiated a session. I want the traffic for that session to come back in. Okay. And then if we're to move to the stateful firewall, and we will do a review of stateless and stateful. Remember, stateless is also the same as packet filtering firewall, so you can use those 2 terms interchangeably. Stateful, we've added the session. And now we have 2 tables. We have a static table and we have a dynamic table. And for every session you initiate, we keep track of that session and we allow the session data back in. Even though the incoming ACLs say deny IP any, well, the data still comes back in. And that is the case for your home wireless access point and my home wireless access point. By default, it doesn't allow anything back in. And that's good. We don't really want people initiated sessions from the outside to come into your house. But any session you initiate from inside your house, from your home side of the firewall, is allowed back in because it is a stateful firewall. And we have those 2 tables, the static table and the session/dynamic table. We have application firewalls, and we can see this with your PC firewall, which is highly capable. And you can also filter on applications. You can say, allow people to run this application, don't allow people to run this application. So not only can you filter on ports, which is a service, but you can filter on an executable file name. So we all know 80 is HTTP, 443 is HTTPS. But what if you have a program that doesn't have a port? Well, you're going to have to allow or deny access to that particular executable file. And this is what an application gateway firewall can do. And NAT, where we are using NAT, and please remember, we're going to lose NAT with IPv6. So NAT is just a workaround. It's one of the 2 workarounds to extend the life of IPv4. And we're not going to need NAT, nor do we want to use NAT with IPv6. So this is a IPv4 specific firewall. So it's going into a little bit more detail here about the packet filtering. What's another name for packet filtering, everybody? Anyone remembers? Okay. Stateless packet filtering is stateless firewall, and it only operates at layer 3 and 4. Okay, so we don't keep track of sessions. This is stateful. This is what we're familiar with. This is what you have inside your PC. This is what you have inside your Windows Server, Linux server, and this is what we have inside our wireless access points. So this is quite popular because we want to prevent people coming in from the outside, but we want to allow the initiated traffic to come back in. Okay. So Cisco uses this term classic to describe all of these guys. So they're saying these are classic firewalls because they do have a next generation firewall, which we'll be talking about, and we have a lab for it. So let's just go over a few slides and then we'll do some labs, and then we'll go over ZPF, zone-based firewall, which is the next generation firewall, and then we'll do a lab for that. Okay, so this is the stuff we've been talking about, everybody. So we want to prevent outside traffic coming in, but we want to allow traffic that is initiated internally to come back in. And this used to be the norm. I mean, this is still the norm for your home wireless access point and my home wireless access point. But if you were to go to a medium-sized, a large-sized company, you know, we can no longer do business this way because we've outsourced everything. And we need access to the outsourced data, and we need it immediately. We're not going to wait for them to send us the data somehow overnight. So when I worked for HP the last 3 years, I was responsible for a system called Virtual Factory. And this is basically all of our contract manufacturers. And we wanted to go and get the data anytime we wanted from their production system. So they had to drill holes in their firewalls to allow us access to their production systems. And guess what? They needed access to our data as well. And then we had to drill holes in our firewalls to give them access. We didn't want to copy the data to a DMZ server, and I will show you that in a few slides. That's just slow, and it's more work. So last time I looked at a Hewlett-Packard firewall, it had hundreds of holes in it, not dozens, hundreds, because we needed to enable our servers to go through that firewall to get to all these contract manufacturers' computers, and many of them needed access to our data, our production data, and then we had to drill holes. So they look like a Swiss cheese. A medium-sized, a large-sized company firewalls look like Swiss cheese with tons of holes. And the trick here is to make these holes as small as humanly possible. So you don't really want to have a hole that says you can have access to this server. No, it's like, you know, what's the source IP? Where are you coming from? And exactly where you're going. And which service do you want to use? So we're not going to give you access to the entire server. We're only going to give you access to this one service. And what is the account name? How are you going to be logged on? Because we can filter on the account name. And what time? Are we going to open it 7/24, or are we going to open it, you know, Tuesday, Thursday from 1 till 1:15? And that's it. You know, that hole is closed the rest of the time. So the more restrictions you add, the smaller the hole is. And the fewer restrictions, the bigger that firewall hole is. And your job is to make those firewall holes as tiny as possible, which means you add as much source and destination information as you can. Does that make sense? Okay. So the idea of a clean firewall, because this is what it used to be, this is how it is inside your house, just a clean firewall. I'm going to allow everything out, nothing can come back in. That doesn't work anymore. This is like old mindset. New mindset, I have all these companies I'm working with, and we need immediate access to each other data, and we have to be able to go through our firewall, their firewall, and vice versa. Okay. Very good. So nothing here. Here we go. DMZ. I hope you're all familiar with a DMZ. Your home wireless access point is capable of putting an IP in your home DMZ. So at home, you have that DMZ capability. And that basically means that that device is on the other side of the firewall. It's not protected. Remember, your wireless access point firewall says nothing can come in. Well, if you were to say this IP 192.168.1.100 is in the DMZ, okay, logically, it's in the other side of the firewall and it's not protected by the firewall. And then you have to heavily depend on the operating system to protect itself. And remember, if it's a Windows device, it has a firewall. So you're dependent on your Windows firewall to protect that device. And we still have lots of DMZs, but they are not as popular as they used to be because, again, if you were to go some years back, companies didn't want to have other companies come inside their network. So they would create a DMZ and then they would put all the devices that they wanted their remote users and contract manufacturers, partners, etc., to access in the DMZ. Well, that doesn't work anymore because we don't want to keep replicating data. And we have much fancier firewalls than we did before. And the new method is we just drill holes into the firewall so employees and contract manufacturers can get inside our network, but they can only get to this one device and they can only use this one service and whatever additional criteria you want to add. So we still have DMZs. I'm not saying DMZs went away. We still have them. I'm just saying, we're less reliant on them than we used to be because that's just an old way of enabling remote users and suppliers, contract manufacturers to access data. And here what we're saying is the outside has access to the DMZ. We have access from the inside to the DMZ, but the DMZ cannot come back inside. So this is what those arrows are saying. So public internet, we have a two-way communication with the DMZ. And remember, we still have firewalls on those computers, and we're using those firewalls on the DMZ computers to protect those computers. And we have communication from the private network to the DMZ, but we cannot come from the DMZ to the private network. And then we can go to the outside world, but we don't want the inside world to come back in. And like I said, this is an old method of securing network and devices. And I'm not saying some people still don't use it. The newer method is I need access to your production systems. And the only way to do this is to drill holes through the production firewall. Zone-based, so this is basically the next generation. This is Cisco's latest and greatest. And here is we're trying to elevate. Remember when we talked about directory services, we said you have local accounts, you have local groups, you have local GPOs, and we want to elevate them. And I think this is the concept here with zone-based firewall, is let's elevate it to a higher level. So it still is a firewall. We're still using ACLs. We're just elevating it. And we're not really going to dive too much. I have one lab, and you have one lab to do for zone-based firewalls. But we're going to keep it at about 1,000-foot level. And if you ever get a job, I don't think there will be expectations that you know how you're a zone-based firewall expert. But I think there's expectation that you understand ACLs very well. And then you can work your way toward a zone-based. And I can't tell you how many people use zone-based because this is a Cisco-specific technology. This is not an open standard. This is a Cisco technology. And I don't really know how widely used it is, but I will make sure you understand it. And again, at a high level, we're just elevating the ACLs to a higher level. Yep, layered defenses, absolutely. So security, physical and otherwise, has to be approached as layered defenses. Position firewalls at security boundaries. It's unwise to rely exclusively on firewalls for all security. It is just a device. So it's just a tool. So you have a tool set of security applications and devices, and firewalls is one. It's a hammer. And it's a very important tool, but it's just one tool. And you need a tool set. You still need anti-malware. You still need intrusion detection, prevention, which is the next chapter. You still need secure passwords. You still need multi way of authenticating users, etc., etc. So it's a tool set, and firewalls is a very, very important tool, but just one tool. Ensure that physical access, absolutely everybody. So I keep saying there is no security without physical security. So we have to make sure that we physically secure access to all of our computing environment, servers, routers, switches, firewalls, etc. Yep. So we capture log data for two reasons. Reason number one is to monitor and see how things are going. And reason number two is if we have an incident, now we can go and mine the logs to capture whatever data we can. What does change management mean to you? I'm asking. So you hear this term a lot, change management. And this applies to lots of different things. What does change management mean to you?
Process of implementing change.
Very good.
Project.
Process. Thank you very much, Cody. Process for implementing change, meaning that you don't really want to just make a change. You don't just change the ACL. You don't just add an ACE to an existing ACL. There has to be a process. And can you name some of those items in the process? What would be item number one in that change management process? Define the need, define the scope. Okay, what changes do you need to make? Make the changes in a test environment. Thoroughly test the changes, right, everybody? And then when you're 100% confident it's good, then you move it into production. So this is what we are talking about when we talk about change management. And the idea here is to make sure that we have a good process that will mitigate errors and security concerns. And this applies to everything. We want a change management process. We don't want someone to log on to the production firewall, router, switch, and do something that would violate the change management process. Okay. And let's do the labs. So the last thing we'll talk about today is ZPF, zone-based policy firewall, and like I said, at a higher level. So let's come labs for, I'm still working. We do have 2 labs for 5. I'm working on labs for 6. I'll have them ready before we need them. So come back here and let's review these. So we have 4-1, 4-2, 4-3, and we have 1 packet tracer file for all of them. And we did these, most of them, last week. And I want to review them before we do a troubleshooting practice and a ZPF lab, straight out of Net Academy. Okay. So this is the internet, this is the outside, and this is your home, this is your network inside. Stateless firewall. So stateless firewalls filter all inbound and outbound traffic based on static rules. So it's layer 3 and layer 4. So we're not capturing session data, nor are we filtering on session data. And this is what Cisco calls a packet firewall. And you can use those two terms interchangeably. Okay. We talked about the security K9 module, and it's disabled, and we don't really need it for stateless. We do need it for stateful, and everything is fully functional. Right now, we don't have any ACLs. No ACLs, meaning everything can come in, go out. Okay. So what do we want to do? We have inside rule for inside the home, and we have outside rule for outside. So IP access extended inside. So this is a named extended ACL. Remember, IPv6, they only have the equivalent of named extended. And we're saying TCP, okay, anything for this class C subnet. I know 10 is a class A, but if you were to look at the subnet mask, okay, this is a reverse subnet mask, the equivalent of 255.255.255.0. So for that class C, and then we're using, we could have stopped. We could have said, you know, TCP, we could have dropped the any, and we have a much larger net. So when it comes to ACLs, you can have a very large net, you can have a medium-sized net, small net, and you can have a spear. And that is good to remember. And a very large net would be something like permit IP any. Everybody, permit IP any, and I will show you what that does. Permit IP any, it's basically I'm saying permit IP any source, any destination, and that's it. I'm not specifying anything else. And that will permit anything above IP. So that includes TCP and UDP, and that includes all the TCP protocols and all the UDP protocols. So you can see this is a very large net. But however, IP doesn't include ACMP, nor does it include IGMP. So if you want to allow ping, then you have to have a second ACE that says permit ICMP, maybe any. Good, everybody? And then if you want to be precise, then you have to specify a protocol, you have to specify a source address, a destination address, and then you have to specify a destination port number. And the vast majority of protocols use ephemeral or a dynamic source port number. So it's not very useful because you don't know what it's going to be. But the destination port number, we know what that is going to be. So I'm going to go back. We may come back here. So I'm saying allow 80, allow 443, and allow FTP. And all of these are TCP. Okay. And then deny IP any. Okay. And you know the implicit last statement is deny any. So we're denying all UDP, we're denying all ICMP. This is all we're permitting. So TCP, not only TCP, the source has to be one of those class C subnet IPs. The destination is any IP, so we don't care where we're going. And then we do care about the destination port number, 80, 443, or 20. And then you can see down here, coming back, deny IP any, so we don't want any IP. And to come back to this table for a second, IP, in the top of it, we have TCP and UDP, and then we have the many protocols that use either TCP or UDP. So when we say deny IP, we're denying everything above IP. And to just focus on TCP and UDP, if you were to just say, you know, deny TCP any and stop, then you're denying all the protocols that sit on TCP. If you were to say permit UDP any, you're permitting all the protocols that rely on UDP. So keep that analogy in mind. how big do you want that net to be? It can be massive or it can be a sphere. And a sphere is much better than a very large net. Does this make sense? So we're only allowing these 3 protocols out, and we're not allowing anything back in. So what's the problem with this ACL before we apply it? And then we apply it to this interface right here, gig 00, inside the home. What's the problem with this ACL? Is this stateful or stateless? Are you guys out there?
Stateless.
Okay, it's stateless. Very good. And what are we allowing back? Deny IP any? So yeah, you know, 80 can get out, 443 can get out, FTP can get out. Will they be able to come back in? And the rule is saying deny IP. And in the top of IP, we have TCP, UDP, and all of their protocols. So let's see this in action. Okay, so I'm going to copy and paste. And I can do show access, and I can see extended IP access list inside. And I do have deny IP any. I didn't even have to put this in there because it's implicit. And from the outside, all I have is deny IP any. So let's go into simulation mode. And of course, ping is going to fail, and it's going to fail at R1 because we didn't permit ICMP. And ICMP is slightly below IP, so it's not going to work. So run ping 172.30.1.150, and by now you know we're going to do the ARP thing to resolve the IP to a MAC address. And now we're doing the ICMP, and it hit the wall. It didn't leave. It didn't leave because our ACL is focused on TCP. Okay, let's do TCP. So from here, let's FTP or let's HTTP into the HTTP server. And let me simulate. And 172.30.1.150. And let's see what's going to happen. It's TCP. And yep, everybody, the rule. So we're doing the ARP thing. Okay, very good. And then we continue with HTTP. Good, everybody. So we got to the destination. We were able to leave the local area network. The ACL allowed us to do this. And let's see what's going to happen now. And in the way back, it said deny IP any. This is a packet firewall. This is a stateless firewall. And we don't have a dynamic table. We don't have a session table. It's just going to look at the static, and the static says deny IP any. Any questions here? We did this before. Okay. So let's move on to the next lab. So let's do the first stateful. And here. Same topology. Okay, so now we're using stateful. And I know I'm repeating myself, and this is by design. And now we have static table, and we have a dynamic/session table. And that's what you have on your PC. This is what you have on your wireless access point. And this is a very, very common form of a firewall, a stateful firewall. And we do need that security K9 module. And let's go ahead and enable it. And show version. Yep, it's enabled everybody. So I enabled it for us, but it's not enabled by default. And you see it says type evaluation, which means, we haven't paid for it. I know this is all packet tracer, but this is good because you can enable this module on a production server and Cisco is going to say, fine, you can play with it for a while just to evaluate it, test it. But then if you want to use it, you're going to have to purchase this module and then it will say permanent after that. So evaluation is good enough for what we are doing. And let's look at the rules. So from this from this base K9 module, I am using this IP inspect, and this is the stateful command, firewall TCP. Okay, so I'm basically saying any TCP because I didn't specify anything after that, so it applies to all TCP. Back to how big of a net do you want to use? And this is fairly large because it's saying TCP. We didn't specify a source and destination IP. We didn't specify a port number. And then on the inside, I don't want all TCP. Remember the IP inspect name, it's all TCP, but I don't want all TCP. I wanted to limit it. And I limited it to www.443 and FTP. So I have two ACLs, a large one and a smaller one. And the large one gives me that stateful feature that I'm interested in, which means those sessions can come back in, but I only want those three kind of traffic to get outside. And then coming back, it's deny IP any. So the only thing I added from before is this when command everybody. This is the only difference between this lab and the previous lab. It's exactly the same, except I added the stateful statement, IP inspect name firewall TCP, and I applied it to the inside interface. So let's copy and see what it's going to do, what this when statement is going to do. And I think you know the answer. It's going to keep track of the sessions and allow them back in. And END, show access, and show run. And let me go to the end, come back. And you can see we enabled the security K9 module. And this is the IP inspect name firewall TCP. And there's a timeout. How long do you want to wait before you time out, before you kill that session from the session table, from the dynamic table? And it defaulted to a value because I didn't specify a value. And if you wanted a bigger value or a smaller value, you go back to the command and you put time out, and then you specify the timeout period you want. But it does have a default value. And then if you were to look under gig 00, we do have the inside access group, and we do have this IP inspect firewall rule. So let's see what it's going to do. Simulate. Okay, FTP, HTTP. So desktop, let's FTP, because FTP is okay, 172.30.1150. And let's follow it. So we're going to do ARP twice. Come back. And it's still green. So you can see, it's working. And it's working because it is a stateful firewall. We initiated the session from the inside. We're allowing the data to come back for that session. And if I was to come to the server and do HTTP, and HTTP will also work because we enabled that as well to come back in. And let me just go real time. Here we are. And here we are. And let me see. Let's look at the session data. Okay. Show IP inspect sessions. And this is the FTP session. So let me redo the HTTP. And it does allow HTTPS as well. So this should work. And come back here. And here they are. This is 21 for FTP, and this is 443. And this is the session table. This is the dynamic table I was talking about. So we have a static table with the ACL rules, and we have a session dynamic table where we keep track of sessions that were created internally. And we do have a timeout period, so we're not going to leave it open indefinitely. We will close it if it closes or after a certain amount of time, and it works much better. And this is the kind of a firewall you have in your PC and you have in your wireless access point. And of course, if I was to log on to this outside server and try to do anything internally, it's going to fail. So if I was to try an FTP to 10.0.0.4, it's going to fail. And it's going to hit the G01 wall, because it said deny IP any. So nothing's going to come in unless it initiated from the inside. Questions?
Zico, I just have one quick thing.
Yes.
So your ACLs, when you apply them, they take precedence over any packet inspection that you do, right?
Ask me the question again, Cody.
So if you apply an ACL on an interface and then you configure packet inspection for TCP or IP or UDP or whatever,
okay.
Those inspection rules, are they always going to obey the ACLs first?
Are you talking about the session rules?
That's right. Yeah. When they're applied, do they?
Yes. Thank you very much. I think this is my take on it. Cody, you can Google it and let me know. I think you start by looking at the static rules and then you look at the session rules.
Got you. Okay. So those take precedence first.
I think that's the order. But
okay.
Please Google it and correct me if I'm wrong. So let's do the next one. Okay. So this is okay. Stateful number 2. Hold on, we did stateless. Okay, let's see what this guy is. And here we are. Same exact topology. So let's see, stateful. Okay, stateful. So we know this. What did we do different here? Okay. From server 1, FTP should fail. Hold on, everybody. I need to remember, what did I do here? What's different? Because it looks the same to me here. So we did this, allow these guys, any outside. Okay, should fail, should work, from server 1, should fail. Why should it fail? We have FTP in here. Okay, let's copy and paste and see. I'm not 100% sure what this lab is going to do, but let's try it. It looks the same to me. T paste. show access. So we're allowing www 443 and FTP, and we're denying everything in show run. So this is the ACL we created. Okay. License 00. Oh, hold on. So version. Yep, security is okay. What am I trying to do here? Give me a second, everybody. So I didn't enable the IP base, but it was enabled before. Yep. Version. Okay. This guy. So we can enable it. Let's enable it. I'm just running through the lab to see what does it do. License, boot, module, C, tech, security, yes. And show version. And now we can see it's enabled, great. And now we can paste this guy. And it's going to work. Okay, here it is. This is enabled. This is the IP inspect. Okay. So let's do the lab. And according to this, FTP should fail. Let's see. 172.30.1.150. Nope, yeah, it doesn't make sense. I don't know what that lab is, everybody, so I'm gonna move on. I'll fix it later. I'll make a note and I will fix it. So let's do the troubleshooting lab. I think that's an interesting one. So I don't know what this 2 is. So let's work on this troubleshooting lab. So let's open it up. Okay. All right. So this is a troubleshooting scenario. Security K9 is already installed. Let me double check. And show version. And yep, it is. Wonderful. And I have these rules. Okay, IP inspect. Okay. Aha, very good. So we changed the coming back in. So before it was deny IP any. Okay, and now I'm saying allow 80 and 443 to come from the outside. Could everybody permit TCP host? So I'm being very particular, and this is really good. Okay, we're making that firewall hole smaller by saying only allow this remote host. Okay, and only to this device. This is really excellent practice, everybody. Okay, allow this one computer from the outside to communicate with this one computer from the inside using 80 or 443, HTTP or HTTPS, and then deny IP any. So that's all we want to allow from the outside. Does this make sense? So we still have the same rule going out. We changed the rule coming back in, and we're allowing permission for one outside computer to communicate with one inside computer using port 80 and 443. So who wants, so take a good look at it. Does it have a hole? Do you see a hole in this scenario? Do you think 172.301.150 will be able to HTTP or HTTPS to server 1 with this IP? What do you guys think? All right, let's apply it and try. And this is a super common mistake. What I want to show you is a very, very common mistake. And I'm hoping you will avoid making this mistake down the road. But let's go through it. And show access. Very good. And you can see the outside rules are different than before. Okay. And show run, it's going to show us this and the IP inspect. And you can see the IP inspect here. Very good. So let's try it out. Okay. And I'm going to go straight into simulation mode. And let's do HTTP because that's the only thing we're allowing from the outside. So if we were to FTP, it's going to fail right away. 10.0.0.4, and it's going to fail right away because we're only allowing 80 and 443 from the outside. We are in simulation, and let's follow it. So we're going to do the ARP thing, and it's going to go red. Good, everybody? It said, nope, you know, you're not 80, you're not 443, we're not going to allow you in. Okay, let it finish. Let's come back to simulation and let's try HTTP. And this would be 10.0.0.4 and let's follow it. Okay. So what's the destination port address, everybody? What's the destination port for this? Here, I'll show you. HTTP. Are you guys out there? Unmute. Come on.
Yeah, I'm here.
Yeah, I'm here.
Okay, thank you. What's the destination port address for this PDU?
I don't know. I don't have that memorized.
What's the port number for HTTP?
Let me Google.
Okay, it's 80, everybody. Okay, so here, let's take a look. So outbound, Ethernet 2, this is the frame. IP is layer 3. TCP is layer 4. Good, everybody? And if we are to look at TCP, you can see the destination port is 80. We can see the destination IP is 10.0.0.4, server 1. The source IP is 150, which is this computer. And then what is the source port? Okay, it's 1026. What is 1026? What does port 1026 tell you?
It's ethereal or inferior or whatever.
Very
right?
good, very good. Ephemeral, okay,
Yeah,
or
yeah.
dynamic. Okay,
Yep.
so it's ephemeral or dynamic. And dynamic means you never know what it's going to be, right, everybody? I mean, right now it's 1026, you know, and 5 minutes later it may be 1035, 1046. It's just a random number that is greater than 1023. And we don't know what that random number is going to be, but right now it's 1026. So you guys tell me what happens when this PDU arrives at server 1 and server 1 is responding back. What happens to the source and the destination IP addresses? So we got to the destination and now the destination is talking back. We flip them, right, everybody? the source becomes the destination, and the destination becomes the source.
Right.
So from 172.30.1150, this is the source. Destination is 10.0.0.4. And then when 10.0.0.4 is communicating back, the destination becomes 172 and the source. The same thing happens with the port numbers. So right now, the destination port number is 80. The source port number is 1026. Well, when server 1 is talking back, it flips them. So the destination becomes 1026 and the source port number becomes 80. So we always flip the MAC addresses, we always flip the IPs, and we always flip the port numbers. Now the MAC addresses, they change from hop to hop, but we still flip them. So router 1 is talking to server 1, router 1 MAC address is the source, server 1 MAC address is the destination, and then in the way back, router 1 MAC address becomes the destination, and server 1 MAC address becomes the source. So keep this in mind, and I'm gonna go back here. Okay, and you tell me what is the problem. So I'm showing you the ACL. So HTTP server is communicating with server 1. We're gonna flip the port numbers, and 1026 becomes the destination port number. And what's gonna happen when we get to R1? R1 is gonna say, if you're 80, you can get out. If you're 443, you can get out. And if you're FTP, you can get out. Well, 1026 can get out. And this is a common firewall error. Because people say, you know, I got in. Well, we don't have, you only have a stateful from the inside. We don't have a stateful from the outside. So just because you initiated a session from the outside doesn't mean the traffic is going to come back in. You still have to comply with the ACL. So let's follow it and see. So we're going to follow. We're going to go to R1. So we're doing the ARC thing. And now we have that TCP. Okay, and it's going to get to server 1. And I'm going to show you everybody. So at server 1 inbound, please take a close look. Source is 150, destination, this is what's coming in, is 10, and source port is 1026, and destination is 80. And then let's look at what's coming out, outbound. Okay. Now 10.0.0.4 is the source, 172.30.1.150 is the destination. We flipped it. And then if we are to look at layer 4, okay, 80 becomes the source and 1026 becomes the destination. And 1026 is an ephemeral, a dynamic port number, and we're not allowing these out. We're not allowing these out. So when we get to R1, we're gonna hit a wall, and let's follow it and see. And voila. And we hit a wall because look at the inside rules going out. We're only allowing 80, we're only allowing 443, and we're only allowing 20 and 21. We're not allowing 1026 to get out. Does that make sense? That's what I wanted to show you. And I wanted to show you this because it's quite common.
Yeah, it makes sense.
Okay. So I want to review very quickly, everybody. I'm not going to go over all the stuff I did before, but I just want to stress how important ACLs are. I want to stress this is a skill you have to master. You have to master for your CCNA. You have to master for your interview. You have to master for your first job. Because if you were hired, you know, next year and you don't know ZPF, they don't really expect you to know ZPF. If you can just answer an interview question at 1,000-foot levels, they will be impressed. And the same thing is true for IDS, IPS, and we'll talk about that on Thursday. They don't expect you to have working knowledge with this stuff. Not, you know, straight out of college. They don't expect that. But ACLs, they expect. they expect you to understand ACLs and be able to troubleshoot them and create them and test them and implement them, all that good stuff. So that is an expectation that every hiring manager is going to have, that you have a firm grip on ACLs. Other stuff like ZPF, IPS, as long as you can answer the interview questions, they'll be impressed. They'll be happy you know what they are. All right. Any questions on this lab? Okay, move on. Permission to move on. So it's going to fail because none of the data is going to be able to go through the firewall in the way back. And yes, it's stateful from the inside. It's not stateful from the outside. Nor do you want it to be. You don't really want it to be stateful from the outside. Moving on. Anything else here? Yeah, sometimes I do this, maybe for me more than it is for you. Before we start troubleshooting, okay, firewalls filter traffic based on the following common criteria as protocols. And there's a longer list of protocols, so we can filter on protocols. Source and destination IPs, it can be a single IP, or it can be, you know, all IPs, or a subnet, or a range of a subnet. So you can be as surgical as you want. Source and destination ports, okay, and remember what I said about the source port. You know, in almost all cases, there's less than a handful of protocols that put a value, a static value in the source port. The vast majority of them use ephemeral or dynamic in the source port. And that's what the troubleshooting lab was about. Is remember this, you know, you don't know what that value is going to be. So you can say to the firewall, open port 1026, okay. But next time it's not going to be 1026, it's going to be something else. So you can say greater than, but then, you know, you're opening a big hole, so you have to be careful. Some firewalls can also filter using other data like username, date, time, application, etc. The firewall inbound and outbound rules perform one of the following three actions: permit, deny, not applicable. And look what it says here. If you permit, you're done. If you're denied, you're done. If it doesn't apply, because that ACE is for a UDP and you have a TCP PDU, it doesn't apply. Or it's for port 80 and you have port 443, it doesn't apply. And then it says, okay, move on to the next ACE. And by now we all know the very last ACE is deny any. So if you get to the end and you haven't been permitted, you're going to be denied. Place more specific ACEs high. So if you want to permit that one IP or you want to deny that one IP, put it up before you get to the more generic ACEs. Firewalls are processed sequentially. That is another common error. Maybe I should add another lab. You have an ACL and then you add an ACE and it gets added at the very end. Okay. And you never, almost always, you're never going to get there. So I've said, you know, just reapply the whole thing, delete that ACL and then reapply it in the correct order. And finally, and this is like a golden rule, one ACL per interface, per protocol, per direction. And this is what that lab was all about. Okay, almost all protocols use an ephemeral source port number, and you wanna remember that one. Otherwise, it's gonna come back to bite you again and again and again, and you don't know what that value is going to be. You don't know, nor should you ever assume what that value is going to be. You just don't know. And if you assume 99.999% of the time, you will assume wrong. All right, let's do ZPF. we're done with this. So we're down to a few slides and one lab, everybody. So who wants to give me a quick summary of ZPF based on what we said before? Zone-based policy firewall. We're elevating, right, everybody? We're elevating the scope. So we talk a lot about scope in my classes, and we're just elevating the scope, because with ACLs and ACEs, it's low level, it's ground level, right, everybody? It's this ACL for this interface, this ACL for this interface. So it's ground level. It's very, very important, but it's ground level. And Cisco said, you know, maybe we can come up with a mechanism whereby we can elevate the scope. So it will be a higher scope, and we can create once and use many times. And that's what ZPF is trying to accomplish. And it is a Cisco protocol. This is not an open protocol. Benefits of ZPF, one more time: zone-based policy firewall. And there may be an interview question about ZPF. And the expectation is not that you have working experience with it, but you just know what it is. And if you give them an elevator answer, you know, a 1-2 minute answer, they'll be quite happy. And if there's a follow-up question, it's just to see, you know, where your technical limit is. And when you're doing a technical interview, they're always going to ask questions you don't know the answer to, because they want to know, you know, where that line is, where the ceiling is. And the only way for them to know where the ceiling is by asking harder and harder questions. Okay. Not dependent on ACLs. It doesn't mean it doesn't use ACLs. It's just not heavily dependent on ACLs. Router security posture is to block. That's always the case. Policies are easy to read and troubleshoot using C3PL. I'll show you what that is. C3PL. Right here. Okay. Cisco Common Classification Policy Language. C3PL allows you to create traffic policies based on events, conditions, and actions. And you will see this events, conditions, and actions when we cover IPS on Thursday. So you don't have to wait very long. So basically, there's a condition that generated an event, and you want to create an action. Make sense, everybody? So you met the condition produced an event, and now you want to do an action. And the action is drop, allow, log, terminate the session, etc. Block that IP, whatever you want to do. And SDM, which is used in that sentence, this is Security Device Manager. This is a Cisco GUI that allows you to configure routers and ACA devices, etc. So it's a tool, and it's always nice to have a GUI. It's better than using a command line interface, especially when you're trying to enable 250 rules or disable 250 rules. You don't really want to do it manually, one at a time. If you have a GUI, you can just, you know, click, 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 unclick, unclick. So it's a little friendlier. That's what GUIs are to use. So this is what those two acronyms are. Okay. When policy affects any given traffic instead of needing multiple ACLs and inspection actions. Everybody, so everything in here is saying, you know, we're elevating the scope. ZPF elevates the scope. So we're not at the ground level, which is exactly where we are with ACLs. Okay. Common design, design steps, everybody. So, well, hold on. Jump, boom, here we go. So you want to determine the zones. Remember, it's zone-based policy firewall. So step number one is you want to determine the zones: inside zone, outside zone, DMZ zone. And the inside zone can be multiple local area networks. This is what's nice about it. This is what's nice about elevating it. It's not just this one interface. It's a bunch of different things. It's a zone. Establish the zone policies, design the physical infrastructure, and identify subsets within zones and merge traffic requirements. We will do a lab. Okay. Okay. So inspect basically means, you know, inspect the traffic and see if it meets or if it doesn't meet. Drop and pass. I hate when companies do this. This is the same thing as permit and deny. So ZPF, they decided to change the terminology from permit deny, which is what we have been using all along, to drop pass. Okay, big deal, but I don't know why they did it. Why don't you stick with permit denied? Because that's the terminology we've been using with firewalls all along. Okay, so remember, inspect is to inspect. And we actually used inspect earlier on, if you remember. I want to show you very quickly. So IP inspect, everybody. So it's to inspect the traffic to see if it meets or if it doesn't meet, and then drop or pass. Okay. And I'm not going to go over these tables, any details, but basically they are showing you how they're going to get to pass, drop, or inspect. Okay. Yes, allow it, deny it, or oh, let's inspect the ACL and see if they're allowed in, out, or not. All right, this is a very, very important slide, everybody. And when I created the lab, I wanted to reference it. So they're giving us the 5 steps. This is Cisco. Step number 1 is create the zones. This is the private zone. This is the public zone. Name it what you want. Identify the traffic with a class map. So create a class map that determines what is allowed and what's not allowed. And then we have to create a policy map. And then we identify the pair. Okay, this is the inside, this is the outside, this is the DMZ. So you have to identify this. And then you apply them to an interface. So these are the 5 steps for creating and applying ZPF. And I'm going to come back to this slide because my lab is going to reference step 1, 2, 3, 4, and 5. Okay. And now they are showing you the commands, and we can do this in the lab. So I'm going to come back here, and let's go over the lab. And this lab is straight out of Net Academy. So these ones I created myself. This one you can see, you know, 4411. I just grabbed a Net Academy lab, and I did it. So let's look at this file. Okay, type right away. ZPF. Okay. So all devices are configured, so we don't have to worry about this. Security K9, which is required for ZPF, is enabled, so we don't have to worry about this. And remember, this is a Net Academy lab, so these are the passwords that they are using. Okay, and mission is permit in-zone devices to access out-zone and deny out-zone devices access to in-zone. Sounds familiar, everybody? You know, just typical stuff you want a firewall to do. So in-zone, you know, is private, and out-zone is the internet. So to come back to this slide right here. Okay, so this private I'm calling in-zone, and this public I'm calling out zone, and you can call it what you want. It's just a name, it doesn't matter. So before we start, we have no firewall rules, so we can do anything we want. There are no ACLs that are denying or permitting, okay? And any device should be able to communicate with any device. Let me just show you what the topology looks like. And I did make a few changes, but this is basically a Net Academy. So this is the in zone, and this is the out zone. And we want to be able to go out, but we don't want to allow them back in. All right, and then the steps. Remember the steps we were talking about, these steps right here: create the zones, identify traffic. And this is what I have in green right here, just to map it to this slide, hopefully to make it easier for you and for me, because I'm not a ZPF expert. I've never used ZPF. So this is what I'm sharing with you today is the extent of my ZPF experience. I can talk a lot about ACLs. I can give you a 10-minute, 15-minute explanation of ZPF. So step one is create the firewall zones, and I called one in zone and I called one out zone. This is the in zone, red is out zone. Identify the traffic. Okay, sometimes there's just no escaping ACLs because we have to determine what do you want to allow out, what do you want to allow in, and that is an ACL. And I'm saying it's a named ACL, fine. Sorry, it's numbered 101 permit IP. Just to show you IP, everybody. IP enables TCP and UDP, so it's a much larger net, and then all the protocols that sit over TCP, because all of these protocols at the application layer are either using TCP or UDP. There is no other protocol for them to use. They have to, it's either TCP or UDP. And if you enable IP, you're enabling TCP and UDP, and you're enabling all the protocols in the top of them. Okay. So basically, I'm saying allow anything from the in zone, 192.168.20/24, which is exactly what this is. Okay. And the destination doesn't matter. That last any is the destination. I don't care what device they want to talk to on the outside. And then we are mapping the access list we created 101, okay, to the class map right here. And then define step number 3. In green, define an action with policy map, and policy map type inspect in to out pmap, policy map, class type inspect in net class pmap, inspect. So we're inspecting, what are we inspecting? We're inspecting the ACL. Good, everybody? So we're not saying allow everything. We're not saying deny everything, because I could have said, you know, drop or pass. But I didn't want to do this. I wanted to inspect. And when you're inspecting for specific ACL. And this is the ACL. I already mapped it to 101. And then identify the zone pair, the in zone and the out zone. Those are the only 2 zones I have. You're not limited to 2 zones. However, when you're doing mapping, you know, you're using 2 zones. Okay, but you can have a 3rd zone, a DMZ zone, and then you can do pairing between the in zone and the DMZ and the out zone and the DMZ, which is what we saw before. Sorry. And assign zones to the appropriate interface. So now you have to tell the router which interface is the in zone and which interface is the out zone. So coming back to our router 3, this is gig 01 and it's the in zone, and this is serial. You can't read it very well, but this is you can see it very well, but this is the serial interface and this is the out zone. So let's copy and paste. Oh, passwords. Cisco CON-PA 55, Cisco EN-PA 55. And paste it. All right, let's do the rest of it. Show run. We enable the security K9, and you can see we have the class map and we have the policy map, and these are our 2 zones. And if I was to look under those interfaces, gig 01, okay, zone member is in zone, and serial 001 is zone member out zone. So this is what we did here. And now we can do whatever meets this ACL criteria from the inside, access list 101 permit IP. So I can do any IP from the inside, and I'm not limited to ports. I'm not limited to destination IP addresses. Any IP from the inside will work. But let me ask you a question. Can I ping? Can I ping from the inside? I will help you. Can I ping from the inside? What do you guys think? I permitted IP, right? Okay.
You should be able to ping from the inside.
Why do you say so, Joey?
ICMP is on the IP stack, so you're enabling.
But remember, they're at the same level. Like here, TCP and UDP are at the same level. So if you were to allow TCP, you're denying UDP. If you are to allow UDP, you're denying TCP, right? Because they're at the same level. And these protocols down here are at the same level. So ICMP is not an IP protocol, it's a peer to IP. Good, everybody? So I'm saying it's going to fail, and this is another common thing. Just because you enabled IP, you're not going to be able to ping, because ping uses ICMP, and ICMP doesn't sit in the top of IP like TCP and UDP do. They sit in the top of IP. ICMP is a peer. In fact, it's a little lower than IP, but let's just say it's a peer, and you will have to explicitly allow it. So my answer is it's not going to work because we didn't allow ICMP. We only allowed IP. So remember that. So let's test it. So let's see if we can ping. And I'm saying it should fail. So I'm in the inside pinging outside 192.168.1.3. And what does the lab say? Hold on. Hold on. It did work. I stand corrected. Okay. But I'm quite confident about what I said here. Okay. So I'm quite confident about it. So I don't know why it worked. So I'm not going to try and troubleshoot it real time. But for me, it shouldn't work because we only permitted IP. And ICMP is not IP. But we should be able to do any IP thing from the inside. So from here, I should be able to FTP to the outside. So that works. I should be able to HTTP. Any IP action should work. 192.168.1.3, that works. So I'm able to use any IP protocol from the inside. And I want to stress, ICMP is not IP, it's a peer. But the opposite isn't going to work because I'm denying everything from the outside. So if I was to come to 1.3 and trying to get in, so let's see if I can. That's not going to work, nor should I be able to do it from a router. All right, let's go. That's going to fail. So this is as far as I can take you with ZPF, everybody. My ZPF knowledge, I don't have any working experience with ZPF. I don't think very many people do. It's the next generation firewall policy from Cisco. It's a Cisco thing. It's not an industry thing. It doesn't mean that other vendors don't have the equivalent of, but it's not ZPF. ACLs is ground level and is a required skill. ZPF, I think if you can talk intelligently about it, just let them know that you're aware of it and you know what it is. And the magic word is we're elevating the scope. Okay, we're elevating the scope. We're giving ourselves more flexibility. So we can create zones and pair them. And that is at a higher level than ACLs, and it gives us some added flexibility. And if you're a large company with multiple sites, your inside zone can consist of all these sites. So you have an inside zone, and it's site A and site B and site C. And your outside zone is the internet, and you have a DMZ zone, and it just gives you that flexibility I was talking about, because it elevates firewalls to a higher scope. Questions?
It makes sense.
Okay, thank you, Alex. I'm glad it makes sense. Any questions on anything we've covered in chapter 4? So just to come back to these and my expectations that you're doing all of these labs on your own, at your own pace. And I really still don't know what this Firewall -2 is. I have to come back and take a look at it. Give me 1 second. I want to see if it's any different than the previous lab. Enable. Stateful. Oh yes, yes. This is very different. Okay, very good, everybody. Let's take a look here. Over here, I'm saying I'm allowing ICMP, I'm allowing TCP, I'm allowing UDP. Cool, everybody. So this is -1, and maybe I never did -1. I think I clicked on -2. This is why -2 looked very familiar, everybody, because I opened it twice. So they are perfectly good labs. I just opened the wrong file. We never did this lab. This is the one lab we never did. But now we all can read this language. Let's read this language together. So IP inspect, firewall, ICMP for ping, TCP, any TCP, UDP, any UDP. And if you remember in the second lab, okay, I only enabled TCP, and then I limited which TCP ports you can use. This is the lab we did. This is the lab we didn't do. Okay. So here it's much broader. Here it's much broader because I'm saying, stateful ping, stateful TCP. I'm not specifying any ports. So any TCP protocol, any UDP protocol. And there's really no need for this because it's implied. And we're never going to get here because we've enabled ICMP, we've enabled TCP, we've enabled UDP. So we've pretty much enabled everything. But if it doesn't meet ICMP, TCP, UDP, it will be denied, whether you have a command that says denied or not. So sorry about that. It's a perfectly good lab. But to go back to my expectations, my expectation is you start from the top and you work your way down to the bottom and you do all that stuff. And the first 2 labs are from 152. This is 285. So this is just a basic review of standard and extended ACLs. And then we did a bunch of additional labs. Any questions on anything we've done with chapter 4? So if I was to run into you in the elevator and ask you what is ZPF, do you think you can give me an accurate 1-2-minute answer?
Probably, yeah.
Okay, and that will be sufficient, Alex. I find it very hard that any company is going to expect you or anyone else to have ZPF working experience. If they use it, they'll train you. And if you understand the ACLs, it will be easier training. I've said this 10 times today and 10 times last week. ACL is a must-have skill. And you can't kick this can down the road. There are lots of other cans you can kick down the road, like the ZPF can, like the IPS can, which is we're covering on Thursday, but not the ACL can. It's just a basic skill set. This is reading, writing, and math. I am done. I'm turning it over to you. I don't think you have very many labs for chapter 4. Cisco, Net Academy. And I have to figure out what to do with chapter 10 because we don't use that GUI tool. And today is Tuesday, so chapter 3 labs, is it 1 lab? It's due tomorrow. And this is chapter 4. Okay, I stand corrected, so you have 3. 2 traditional and 1 ZPF. Well, thank you very much, everybody. You have a wonderful day, and we will go over IDS, IPS on Thursday. You have a good day.
Yeah, Zico?
Yes.
I have problems remembering stuff, but like I can definitely remember all this. I just can't explain it. That's my problem with a lot of stuff.
Very good, and I appreciate your honesty, Robert. But sooner or later, you're gonna go for a job interview.
Yeah, I write a lot of stuff down though. I always take notes, and I always look stuff up if I can.
And there are stuff that you don't have to explain. I mean, I don't know is a perfectly good answer, but you don't want I don't know to be the answer, right? So if they say, you know, give me an example of how to use ZPF, you can say, I don't know. And I don't think they will be terribly disappointed. But the basic stuff, they expect you to be able to answer those questions. Yeah. And maybe you can practice, Robert.
Yeah, like I know stuff inside my brain, but I just can't like explain it. I'm really put at explaining stuff at times.
I hear you.
Explaining myself.
I hear you. Do you think practice would help?
Yeah, I practice sometimes actually in front of my dad. He's a networker.
Good.
Like he's a programmer and he knows like networking stuff. Yeah. Kind of. So like I explain stuff to him and tell stuff to my brother at times.
That's good. And I want you to know, 80% of the interview questions are known before the interview.
Yeah.
So I would say, Google, common network and system administration questions, and you will be surprised. A lot of them are the same, and it makes sense. And then bare minimum practice those ones. So be prepared to answer those basic questions, and those are most of the questions. And there will be some questions that will be challenging, and some questions you don't know, and just say, I don't know.
Okay.
And I
normally try to ask as many questions as I can, but it's hard for me to come up with questions like on the spot because I need to think about it because I need to think about it for a bit. Yes. And then I can answer it.
Yeah.
Ask it. So.
Okay. All right.
Well, thank you.
You are most welcome, Robert. Talk to you later.
Yep. Talk to you Wednesday.
You bet. Tomorrow.